This video is going to show you the video solution for the inelastic collision, which is a recoil example. This is where one object becomes two, or becomes multiple objects actually. So here's the problem setup. Before the collision, I have a truck that's carrying a car on its back, and they're both moving at 2 meters per second. Something happens, and the car slides off, and boink, it hits the ground. So it's rolling backwards when it hits the ground at 4 meters per second, and the question is, what's the speed of the truck after the car starts rolling backwards off of the rear of the truck at 4 meters per second? So here I have the classic recoil problem, where I have one object that splits into multiple objects after something happens. To solve this, I start with summing up the momentum before and summing up the momentum afterwards. So sigma lowercase p subscript before equals sigma lowercase p subscript after. This is the mathematical way of saying that all the momentum is conserved before and after our little interaction. Then I look at it, and I've got one object on the left, so that's how many momentums I have on the left. One momentum. The sum of the masses times one velocity. On the right, I have it split into two separate objects, so I have two separate momentums. Momentum of the car with the subscript c, and momentum of the truck with the subscript t. And then I start putting in the numbers. So I have the combined mass of the car and the truck times the velocity, and they're both moving at the same velocity since they're connected. After the collision, I have the car at 1,000 kilograms, moving at 4 meters per second. But it's not just 4 meters per second, it's moving in the opposite direction that it was in the beginning. Because it's opposite, I use a negative sign. That's what negative signs mean. It means the opposite direction. Plus the unknown velocity. That's 3,500 kilograms times v. And now I have an equation I can solve for v. So I'll suppress the units, do a little bit of math. I'll divide every math expression by 100. And that gives me 45 times 2, which is equal to negative 10 times 4 plus 35v. Do a little more math. Move the 40 on the other side to give me 130 is equal to 35v. And that solves giving me a velocity of 130 divided by 35 meters per second. And this is what your paper would look like. So I've got all the steps here on the paper. I've got some of the momentum before and after, so that's my statement saying I'm using the law of conservation of momentum. And then I'm describing how I'm using the law of conservation of momentum in terms of how many objects. One object on the before side splits into two objects on the right. Then I have my numbers and units, all shown on the next line. A little bit of math to see how I get the final answer. And then finally, the final answer. So I have it a fraction. It's okay to have it as a decimal, but in this case I just have a fraction of 130 over 35 meters per second.